So, good day everyone. Today we will present the philosophy of AI, deep learning, and machine learning. First is philosophy of AI. The philosophy of artificial intelligence is a collection of issues primarily concerned with whether or not AI is possible, with whether or not it is possible to build an intelligent thinking machine. Also of concern is whether humans and other animals are best thought of as machines themselves, and the most important of the whether possible problems lie at the intersection of theories of the semantic contents of thoughts and other nature of computation. A second suit of problems surrounds the nature of rationality. A third suit revolves around the semi-transcendent reasoning powers of the human mind. These problems derive from Kurt Gödel's famous incompleteness theorem. And a fourth collection of problems concerns the architecture of an intelligent machine. Should a thinking computer use discrete or continuous modes of computing and representing? Is having a body necessary? And is being conscious necessary? This takes us to the final set of questions, which is, can a computer be conscious? Can a computer have a moral sense? Will we have duties to thinking computers, to robots? For example, is it moral for humans to even attempt to build an intelligent machine? If we did build such a machine, would turning it off be the equivalent of murder? And lastly is, if we had a race of such machines, would it be immoral to force them to work for us? The very nature of the term artificial intelligence brings up philosophical questions whether intelligent behavior implies or requires the existence of a mind, and to what extent is consciousness replicable as computation. The philosophy of artificial intelligence attempts to answer such questions as follows. Can a machine act intelligently? Can it solve any problem that a person would solve by thinking? Are human intelligence and machine intelligence the same? Is the human brain essentially a computer? Can a machine have a mind, mental states, and consciousness in the same sense that a human being can? Can it feel how things are? Questions like these reflect the divergent interests of AI researchers, cognitive scientists, and philosophers, respectively. The scientific answers to these questions depend on the definition of intelligence and consciousness and exactly which machines are under discussion. How much does philosophy practice? How does much philosophy matter in practice? The definition of intelligence, natural or artificial, and consciousness appears to be extremely evasive and leads to apparently never ending discourse. In an intellectual company, this discussion can be quite enjoyable in the absence of suitable company, books such as The Minds by Hofstadter and Dennett can offer stimulation. However, as John McCarthy pointed out, the philosophy of AI is unlikely to have any more effect on the practice of AI research than philosophy of science generally has on the practice of science. Thus, we will continue investigating systems that are helpful in solving practical problems without asking too much whether they are intelligent or just behavior as if they were.
Learning, which is itself a subset of artificial intelligence. The concept of AI has been around since the 1950s, with the goal of making computers able to think and reason in similar ways to humans. As a part of making machines able to think, machine learning is focused on how to make them learn without being explicitly programmed. Deep learning goes beyond machine learning by creating more complex hierarchical models meant to mimic how humans learn new information. Neural networks drive deep learning, are inspired by the way the human brain is organized. The interconnected network switches that make up these neural networks are constructed with the goal of learning to detect patterns in a manner similar to that the brain and nervous system of humans. A model is a mathematical algorithm that has been taught to arrive at the same conclusion or prediction that human expert would make, given the same data in the context of AI and ML. How does deep learning work? Deep learning training takes time and requires ingesting and testing against enormous volumes of data as the system steadily improves its model. Neural nets have been around since the 1950s, but only in recent years have the both computational power and data storage capabilities advanced to the point where deep learning algorithms can be used to create exciting new technologies. For example, deep learning neural networks that have made it possible for computers to carry out tasks like speech recognition, computer vision, bioinformatics, and medical image analysis, while making machines capable of tasks that would otherwise require human intelligence was the first aim of AI. The concept has been improved. Deep learning aims to make it easier for machines to pick up new skills. Data scientists choose the rules and data set properties to include in model for rule-based AI and machine learning, which defines how those models function. Francois Cholet, an AI researcher at Google and creator of the machine learning software library Keras, says intelligence is not skill itself. It's not what you can do. It's how well and how efficiently you can learn new things. The data scientists feed raw data into algorithm for deep learning. The system then examines such data without having any predetermined rules or features. Once the make system makes its predictions, they are checked against a separate set of data for accuracy. The level of accuracy those predictions or lack of thereof then informs the next set of predictions the system makes. The deep learning refers to the many layers of the neural network accumulates over time, with performance improving as the network gets deeper. Each level of the network processes its input data in a specific way, which then informs the next layer, so the output from one layer becomes the input to the next layer. The current applications of deep learning, especially in the healthcare, companies in many sectors applying deep learning models to address a variety of use cases. Below are just a few of main applications of deep learning in the real world. Healthcare. The medical sector today produces enormous amounts of data. There are several ways in which speedy and accurate data analysis might influence better patient outcomes. Deep learning algorithms are being applied in areas such as medical research, imaging analytics, disease prevention, guided drug improved development, and natural language processing, which can be especially helpful for filling the free text clinical notes in the electronic healthcare records. Manufacturer also must provide goods and services of greater quality more quickly and expensively. Computer-aided engineering is being used by many businesses to cut down on the time, money, and resources needed to create physical prototypes for testing new products. Deep learning can be used to model very complex patterns in multidimensional data and improve the analytics accuracy of testing data. For financial services, in many businesses, fraud is an increasing issue, but financial service providers are particularly vulnerable. Deep learning can be used to swiftly and affordably identify out-of-pattern behavior. Insights delivered from deep learning models can also help more accurately evaluate the predict risk of loan applicant, predict stock values, automate back office operations, and advise clients on financial products. Public sector government organization can utilize deep learning to the effectiveness of civil employees as more departments, system, and procedures are digitalized. Finding people of interest in public places can be made simpler for law enforcement through image detection and classification. Visa and immigration applications can be streamed with algorithms that automate certain aspects of processing. Airports are also using deep learning to improve security, enhance operations, and automate queue management. Deep learning models can be even used to help predict traffic conditions and allow local authorities to take proactive steps to ease road congestion. So let's go for the machine learning. What is machine learning? So machine learning is a type of artificial intelligence that allows application to become more accurate at predicting outcomes without being explicitly programmed to do so. Machine learning algorithms use historical data as input to predict new output values. Our recommendation engines are common use for machine learning. Other popular uses include fraud detection, spam filtering, malware threat detection, business process automation, and predictive maintenance. Why machine learning is very important for this era? Machine learning is important because it gives enterprises a view of trends in customer behavior and operational business patterns, as well as support the development of new products. Many of today's leading companies such as Facebook, Google, and Uber make machine learning a central part of their operations. Machine learning has become a significant competitive differentiator for many companies. So there are different types of machine learning. Supervised learning, in this type of machine learning, data scientists apply algorithms with labeled training data and define the variables they want the algorithm to assess for correlations. Both the input and the output of the algorithm is specified. Supervised machine learning requires the data scientist to train the algorithm with both labeled inputs and desired outputs. Unsupervised learning, this type of machine learning, involves algorithms that train on unlabeled data. The algorithm scans through datasets looking for any meaningful connection. The data that algorithms train on, as well as the prediction or recommendations they output, are predetermined. For the semi-supervised learning, this approach to machine learning involves a mix of two preceding types. Data scientists may feed an algorithm mostly labeled training data, but the model is free to explore the data on its own and develop its own understanding of the data set. Semi-supervised learning works by data scientists feeding a small amount of labeled training data to algorithm. The performance of algorithms typically improves when they train on labeled data sets, but labeling data can be time-consuming and expensive. Semi-supervised learning strikes the middle ground between the performance of supervised learning and efficiency of unsupervised learning. So for the reinforcement learning, data scientists typically use reinforcement learning to teach a machine to complete a multi-step process for which there are clearly defined rules. Data scientists program an algorithm to complete a task and give it positive or negative cues as it works on how to complete a task, but the most important, the algorithm decides on its own what steps to take along the way. Data scientists also program the algorithm to seek positive rewards, which it receives when it performs an action that is beneficial toward its ultimate goal, and avoid punishments when it receives when it performs an action that gets it farther away from its ultimate goal. Uh, Today, machine learning is used a wide range of applications. Perhaps one of the most well-known examples of machine learning in action is the recommendation engine that powers Facebook newsfeed. Customer relationship management. Machine learning models can be used by CRM software to analyze email and remind sales team members to reply to the most crucial communications first. Even prospective solutions can be recommended by more sophisticated systems. For the business intelligence, in order to recognize potentially significant data points, chance of data points, and anomalies, business intelligence and analytics suppliers include machine learning into their software. For the self-driving cars, even a semi-autonomous automobile may be able to distinguish a partially visible item and notify the driver thanks to machine learning algorithms. Virtual assistants, smart assistants, typically combine supervised and unsupervised machine learning models to interpret natural speech and supply context. While machine learning algorithms have been around for decades, they attend new propriety as artificial intelligence has grown in prominence. Deep learning models, in particular, power today's most advanced UI applications. Machine learning platforms are among enterprises' technology most competitive realms, with most vendors, including Amazon, Google, Microsoft, IBM, and others, racing to sign customers up for the platform. Services that cover the spectrum of machine learning. Learning activities including data collection, data preparation, data classification, model building, training and application deployment. As machine learning continues to increase in important to business operations and AI becomes more practical in enterprise settings, the machine learning platforms wars will only intensify. Continued research on the deep learning and AI is increasingly focused on developing more general applications. Today's AI model requires extensive training in order to produce an algorithm that is highly optimized to perform one task. But some researchers are all exploring ways to make models more flexible and are seeking techniques that allow a machine to apply context learned from one task to future and different tasks for the future also. That's all. Thank you.